All right, guys, how you doing?
We're good. So our team is the Typin Utes.
That's right.
This is Frammy, and this is Group. And we create a Battleship game using wireless communication between two FPGA boards. So, if you want to check out our demo over, or our little setup over here, we have two FPGA boards. Each FPGA board is connected to an Arduino. That Arduino is connected to a Bluetooth. That Bluetooth is sending and receiving data from another Bluetooth, which goes to another Arduino and to another FPGA board. One FPGA board is connected to Pirates of the Caribbean music, and both FPGA boards are running a VGA screen. Okay, and of course we also have an SNES controller integrated with with each board. Now I'll turn the time to Trammy, who will talk a little bit about the wireless communication.
So basically, every time it receives an input from the SNES controller, it sends it to the FPGA, it retrieves the data, sends it back out, and the Arduino picks up the data, stores it, sends it to the Bluetooth, Bluetooth sends it to the other side, it picks it up and then displays the data back onto the screen.
Put up some stuff.
So what we're basically doing is, for our Battleship game, we're going to place five placements of ships. Once we have all 5 ships set, we make them, one player makes the move.
So she set her 5 ships, just waiting for mine to set my 5 ships. Now it's my turn, so I can take turns trying to attack her ship. So I'm going to guess that she has a ship at
there you go.
2. So I think that I got a black X because I missed the ship, and now it's her turn.
I make a move. If I make a hit, it should turn red. But since I did not place at the right ship, it's not red. It places a black to indicate a miss.
So now if I try B2, I get a red X because she has a ship located at location B2, and now it's her turn.
The game will keep on going until all players, each one of the players hits all the opponent's side of the ships. And once I've hit all of his ships, the player, one of the screen will display a winning and a losing.
So how the game is actually working inside is when a player selects a square to attack, their FPGA sends the X and Y coordinates through the Bluetooth connection to the other FPGA, and that calculates whether it has a ship at that X and Y. If it does, it sends back a hit. If it doesn't, it sends back a miss. And if it's a hit, the FPGA updates its screen with the red X, otherwise it updates it with the black X. And then the software just cycles through and alternating between each player taking a turn and waiting for an input.
The biggest issue that we did come across is having the communication to work between the Arduino and the FPGA, because the UART on FPGA runs at an asynchronous clock. It does have some issue for this to actually indicate when data is actually picking up data from the FPGA. So that was one of our complications that we had to come across while doing this project.
Anything special about the processor or the VGA controller or any other peripherals?
We use 16 by 16 glyphs, and actually all of these are 42 by 42, so each one of these is actually a 3 by 3 set of glyphs.
Very well.
And that requires some tricky arithmetic in our assembly code. And our assembly program is actually 1,300 lines at this point.
That's right. And we got Pirates of the Caribbean playing, so that's pretty cool.
Best song ever.
Yeah?
So,
Keep talking.
Yeah?
Is there anything else you guys want to put out? All circuit board, handmade, very cool.
It's incredibly difficult to test two FPGA boards because you never know what the other side's doing.
Exactly. So communication is always an issue.
And one thing that we ended up doing was just recording on the LEDs to determine whether or not we were actually sitting and receiving data.
That's right.
And the biggest thing that we had to rely on when we were stuck with actually determining when data was being sent out of the FPGA, we used one of those waveform generators so that it can pick up the signal to allow us to see a visual, an indication for us to know when data is actually being sent out, when is it being received. So that's how we know that the FPGA is actually doing something or when the Arduino is actually doing something.
And because it's so hard to debug the wireless communication, since it's asynchronous, we had to rely on a bunch of assumptions, and if they were wrong, we had to just sit down and think really hard about what was going on.
Very good job, guys. Thank you very much for all your hard work.
Thank you.